climate change mitigation scenarios are possible futures in which global warming is reduced by deliberate actions, such as a comprehensive switch to energy sources other than fossil fuels. A typical mitigation scenario is constructed by selecting a long-range target, such as a desired atmospheric concentration of carbon dioxide, and then fitting the actions to the target, for example by placing a cap on net global and national emissions of greenhouse gases. An increase of global temperature by more than 2 degrees Celsius has come to be the majority definition of what would constitute intolerably dangerous climate change, with efforts to limit the temperature increase to 1.5 degrees Celsius above pre-industrial levels per the Paris Agreement. Some climate scientists are increasingly of the opinion that the goal should be a complete restoration of the atmosphere's pre-industrial condition, on the grounds that too protracted a deviation from those conditions will produce irreversible changes. Target levels of CO2 contributions to climate change, whether they cool or warm the Earth, are often described in terms of the radiative forcing or imbalance they introduce to the planet's energy budget. Now and in the future, anthropogenic carbon dioxide is believed to be the major component of this forcing, and the contribution of other components is often quantified in terms of parts per million CO2 equivalent, or the increment-decrement in carbon dioxide concentrations, which would create a radiative forcing of the same magnitude. At present, non-CO2 contributions to climate change, positive and negative, are believed to roughly cancel out, so that the net radiative forcing being experienced at present, expressed in ppm CO2e, is more or less the same as the actual current level of carbon dioxide. To some extent this legitimates the statement of targets just in terms of ppm CO2, as is usually the case. However, the positive and negative non-CO2 will not necessarily balance in future, and so a target stated in terms of CO2e is less ambiguous. Stabilization wedges. A stabilization wedge is an action which incrementally reduces projected emissions. For example, a reduction in electricity demand due to increased efficiency means that less electricity needs to be generated and thus fewer emissions need to be produced. The term originates in the stabilization wedge game. 350 ppm. This is the target level advocated in a 2008 paper by climate scientist James E. Hansen and others such as Rajendra Pachauri, the chairperson of the UN's Intergovernmental Panel on Climate Change, the director of the University of Minnesota's Institute on the Environment, Jonathan Foley, president of the Pacific Institute Peter H. Gleick, and the policy director of the Brookings Institution's Climate and Energy Economics Project Del C. Morris. This maximum level is advocated by the 350.org campaign, along with other organizations such as the Tallberg Foundation. A strategy proposed is no further oil and gas exploration, the elimination of all uncaptured burning of coal by 2030, and an intensive program of reforestation and negative emissions with technologies such as BECCS, bioagriculture and/or direct air capture. A mitigation scenario modeled by Malte Meinshausen et al. Suggests that to stabilize CO2 at 350 ppm, we will need to reduce emissions by slightly more than 5% per year. The amount of CO2 that has been released to date is believed to be too much to be able to be absorbed by conventional sinks such as trees and soil. In order to reach low emission targets, which implies that negative emissions with technologies such as BECCS are needed to reach the 350 ppm target. From an energy technology and policy perspective, Joe Romm says a 350 ppm target will require 8 wedges, each saving 1 gigaton of carbon per year by 2030 and another 10 by 2060. Nicholas Stern of the Stern Review on the Economics of Climate Change, called the world's top climate economist, endorses 350 ppm as a very sensible long-term target. In a 2009 report, Johan Rockström states 350 ppm is one of the planetary boundaries for CO2 in the atmosphere. We can afford to save the planet. October 23, 2009. Eben Goodstein, Frank Ackerman, Christian Sheeran of the Economics for Equity and the Environment Network, and Lester Brown. We only have months, not years, to save civilization from climate change. November 2009. Who are supporters of the 350 upper limit? World Changing's Alex Stefan. 350 ppm also supports achieving the 350 ppm goal, such as in planetary boundaries and the new generation gap. Stiga Foundation policy, stabilize CO2 in the atmosphere at 350 ppm. Barbara King's Over at Begley, Bonnie Raitt campaign to cap carbon pollution at 350 ppm. In her speech, The World's Tipping Point, Bianca Jagger states the safe upper limit for atmospheric CO2 is no more than 350 ppm, and quotes the report The Economics of 350, The Benefits and Costs of Climate Stabilization by Stephen J. DeCanio, Eben Goodstein, Richard B. Howarth, Richard B. Norgard and Catherine S. Norman, stressing the need for immediate, direct intervention. Scientific American, August 2010. Ocean acidification article threatening oceans from the inside out. How acidification affects marine life. Blue Ocean Institute authors Miraj J. Hart and Carl Safina support 350 ppm as the maximum upper limit of carbon dioxide in the atmosphere for marine life health. See page 72 in print. 450 ppm. The blue scenarios in the IEA's Energy Technology Perspectives publication of 2008 describe pathways to a long-range concentration of 450 ppm. Joseph Romm has sketched how to achieve this target through the application of 14 wedges. World Energy Outlook 2008 mentioned above also describes a 450 policy scenario, in which extra energy investments to 2030 amount to $9.3 trillion over the reference scenario. The scenario also features, after 2020, the participation of major economies such as China and India in a global cap-and-trade scheme initially operating in OECD and European Union countries. Also, the less conservative 450 ppm scenario calls for extensive deployment of negative emissions, i.e., the removal of CO2 from the atmosphere. According to the International Energy Agency and OECD, achieving lower concentration targets depends significantly on the use of BECCS. 550 ppm. This is the target advocated in the Stern Review, as approximately a doubling of CO2 levels relative to preindustrial times. It implies a temperature increase of about 3 degrees. According to conventional estimates of climate sensitivity, Pakala and Sokolow list 15 wedges, any 7 of which in combination should suffice to keep CO2 levels below 550 ppm. The International Energy Agency World Energy Outlook report for 2008 describes a reference scenario for the world's energy future, which assumes no new government policies beyond those already adopted by mid-2008 8, and then a 550 policy scenario, in which further policies are adopted, a mixture of cap-and-trade systems, sectoral agreements and national measures. In the reference scenario, between 2006 and 2030 the world invests $26.3 trillion in energy supply infrastructure. In the 550 policy scenario, a further $4.1 trillion is spent in this period, mostly on efficiency increases which deliver fuel cost savings of over $7 trillion. Other greenhouse gases. Greenhouse gas concentrations are aggregated in terms of carbon dioxide equivalent. Some multi-gas mitigation scenarios have been modeled by Mineshausen et al. As a short-term focus. In a 2000 paper, Hansen argued that the 0.75 degrees Celsius rise in average global temperatures over the last 100 years has been driven mainly by greenhouse gases other than carbon dioxide, since warming due to CO2 had been offset by cooling due to aerosols, implying the viability of a strategy initially based around reducing emissions of non-CO2 greenhouse gases and of black carbon, focusing on CO2 only in the longer run. This was also argued by Vera Bardhan Ramanathan and Jessica Seddon-Wallach for September-October 2009 Foreign Affairs.